Where are you at? Okay, sorry guys, I am running a little late. Bear with me. I'm still here. I had to run to the supermarket real quick and grab some things, and that's why I was late, but I am here now, so here we go. Let's see who's in the room, and okay, let's get started. Wow, we got a ton of questions here, and that is good. So we can jump right in and try to get the most out of this live stream. I just want to make sure this is stable. It is. And we will jump in. So, question number one. Well, let me pull it up on a different screen. Okay. All right. I'm just pulling up on a different screen, and then we will jump in. Okay, so why can't I slide this? All right, let's check my screen's resolution, and maybe that will help, and it does. Okay, so question number one. Of course. All right, so the question states, the hour hand of a clock is 3 feet long. All right, so we have a clock. And we have a hour hand. And then we would have the minute hand, which is longer. Okay, so This hour hand is 3 feet long. All right. And how many feet does the tip of this hand move between 1 and 5 p.m.? So first off, we're at the 1 o'clock position. This would be 2, this would be 3, this would be 4, 5, 6. And I know it's off a little bit, but what we need to know is how many degrees are there in between the hours. Okay, so we have 1, 2, 3, 4, 5, 6 sections, which equal 180 degrees. All right. So we have 30 degrees per section. And the question they're asking is, how many feet does the tip of this hand, just the tip of this hand, move between 1 and 5 p.m.? All right. Now, if we're looking at arc length, don't worry about that. Let's just pretend we have 3 feet. Well, we're not pretending, we do have 3 feet, but I'm trying to just really make me a nice, pretty little circle there. All right, 3 feet. And this hand moves from the 1 o'clock position to the 5 o'clock position. So it moves 30, 60, 80, 90 degrees. No, 120. 1 to 2 is 30, 2 to 3 is 30, 3 to 4 is another 30, and then so this hand will have moved 120 degrees. All right. So the hand is 3 feet long, and so they want to know from here to here, what is this arc length? All right, it is 120 degree arc length. And so at this point, and I see a couple people jumped in. All right, so the question is stating the hour hand of the clock is 3 feet long. How many feet does the tip of this hand move between 1 and 5 o'clock? And we have established that this has moved 120 degrees. So 120 degrees is interesting because it is 1/3 of a circle. And so if I want to calculate distance, I'm going to use the circumference, because the circumference is like a perimeter around the circle. It's the distance around the circle. So instead of trying to calculate 120 degrees, I'm just going to calculate it for a whole entire circle and then use 1/3. Now, the way that they fashion these answers are, we have 2 pi, 4 pi, 6 pi, and 8 pi. All right, so these are our answers up top. Now, so like I said, when I look at this, I understand that the hand moves 120 degrees. The circumference formula is 2 pi r. All right, so 2 times pi times r. Now, the fact that the answers are all in pi, we really don't have to do too much calculations. It'll be like the entire thing will be 2 times the radius. The radius is 3 feet. So the radius or the circumference would be 6 pi, because 2 times 3 feet is 6 pi. And since they're only concerned about 1/3 of the distance of travel, then it is 1/3 of this, the circumference. So our answer would be 2 pi. And Skull Farms, thank you for connecting with me, and what am I trying to say? I turned around and got thrown off. But thank you for subscribing. I appreciate it, man. And tell people about me. And what is your location and the test that you are preparing for? So to recap this question, all right, the hour hand is 3 feet long. How many feet does the tip of this hand move between 1 and 5 p.m.? So at 1 o'clock we're here. We established that, half of this would be 180 degrees, so each section is 30 degrees. So from 1 o'clock to 5 o'clock, we move 30, 60, 90, 120 degrees. We understand that 120 degrees is 1/3 of the degrees required for a circle. So I decided to just do the circumference formula, which is 2 times pi times r. And we established that the radius is 3 feet. 2 times 3 is 6. So 6 pi is the entire distance around the circle. But they didn't ask for that. They want to know from 1 to 5 o'clock, which is 120 degrees, which is 1/3. So if we divide 6 pi by 3, we will get 2 pi. And that is our answer. Okay, ASVAB and SIFT. Okay. Make sure you look at Skull Farms. Make sure you look at some of the previous videos, because there's a lot of helicopter aerodynamics in there that you will need to know for the SIFT. Okay, so that was question number 1 that we had gotten an email today. All right, let's go with another question. And if you came in on the back end of this, don't worry, this is DVR. I don't erase them. So as soon as I hit finish, it will be published. Okay. Now, wow, the typeface is very, very small here, but I will see if I can, there we go, I got a slider. Okay. So the next question is basically a geometry question, and it's saying, in the figure below, what is the measure of the angle X? And I am going to draw it out on the board, so don't worry, because you guys can't see the picture. There's going to have to be a way I can get I'm going to have to get like a green screen for the live stream so you guys can actually see these questions. And then I can do more calculating and less artwork. But at any rate, I'm not complaining, guys. I'm not complaining, but if I can do something more efficiently, I will. That's all I'm saying. So we have a circle. Man, my circles are starting to get kind of good, man. All right. O is the center of the circle. And then we have a triangle that kind of goes like this and like that and like that. Yeah. And then we have the angle X here. And then we have alpha here, and we have point Bravo here. And what they're telling us is this arc length is 70 degrees. And okay, yeah, it's getting all that. I'm just making sure. So this arc length is 70 degrees. So the question is, in the figure below, which is this figure, what is the measure of angle X? All right. Let's look at our options. Our options are 35 degrees, 45 degrees, 55 degrees, and 70 degrees. All right, so 35, 45, 55, and 70 degrees are our options. So as I look at this, I see alpha and Bravo, and then I have C 70 degrees. So the angle AOB is 70 degrees. All right. Now, a little crowd participation, guys. How many degrees are in a triangle? Oh, wait. I know there's a delay. 180. Anybody agree with Cody? Okay, we got two 180s, and I'll take that. So there are 180 degrees in a circle. So if this angle here is 70 degrees, then we only have 110 degrees left to make all the angles of this triangle equate to 180. So 110, we split that in half, we will get 55 degrees and 55 degrees. So the answer is C as in Charlie. All right, 55 degrees when they're asking for the measure of angle X. All right, so to recap, the question asked us in the figure below, what is the measure of the angle X? All right, this was the original. We had the circle, we had point O, we had point A, we had point B. And we had this angle here, 70 degrees, which is telling us that angle AOB, which is this angle, is 70 degrees. We established that there's 180 degrees in a triangle. So if we subtract 70 degrees from 180, then we have 110. So in this case, these two angles have to equal the 110. And since they're kind of, you know, a part of this bisection bang, then they share equally because this angle's coming off one point. So 55 degrees here, 55 degrees here, so X is 55 degrees. Okay, how do you know angle O is 70 degrees? Well, it's formed by this angle, AOB. AOB. So this internal angle here has to be 70 because it's depicted out here. That's why they put it there. They're showing you that, hey, this angle here, 70 degrees. So this triangle is a part of those points. Actually, the O is too. This is the vertex. So it's a part of those points. So if this angle formed is 70 degrees, this angle is 70 degrees. And are we clear on that, Cody? Definitely want to make sure you're clear. Okay, outstanding. All right, now let's go to another question. And guys, new to the room, my guys that are new to the room, new subscribers, okay, you get your test prep book. You take your smartphone, you can take the picture, and you can send it to my email here. So, you know, during the week, if you run into questions, if you are not a client of mine, you don't have to be a client of mine for this live stream. The live stream is free. So, you know, you take pictures and you just send them to my email, which I've just posted, kinothomas@gmail.com. And, you know, I'll answer your questions. If you're having trouble, you know, floating through your book, this is the place where you come to every Friday night, 9 to 11, or 9 to 10 for the regular guys. So, that is that question. All right. Okay. The next question I'm going to address deals with distance, rate, and time. There are various types of distance, rate, and time problems. And I'm sorry. Wrong screen. I'm getting it together, guys. Don't worry. All right. So there are many types of distance, rate, and time problems. But a lot of people look at the basic ones like, okay, if Johnny drives 2 hours at 100 miles an hour, how much distance is he going to cover? And that would be 200 miles. This is like a basic one that you would rarely see. They're not going to give you regular ones like these. Maybe one, you know, but you're either going to get an expansion or compression or a delayed departure. All right, so one question that I found was kind of interesting and would give me an opportunity to demonstrate for you guys. Just keeping everything in check. I tell you guys, with word problems, we do everything line by line. Line by line. All right, so I'm trying to put it on this screen so at least you guys can see. And I can do it. Give me a moment, guys. Because I want it on the message board so you guys can see it and you guys can read along with the, so you guys can read along as I execute the question. All right, so there we go. There you go. There you go. This is probably one of the first types of questions that I kind of cover with my guys. And you just have to keep everything structured. They're really not that hard. Yes, and the question fits. So here's the question, and everybody in the room can see it now. So all this operates under, the formula distance, rate, and time, but sometimes you're not just going to get that straight formula or straight question like I just showed you, like Johnny drives 2 hours at 100 miles an hour. How many miles does he cover? That's easy. This is how you're going to be presented the question in this room that's on the message board. So line by line and diagram. I will say that till I'm blue in the face because that's all you need to do. An aircraft carrier made a trip to Guam and back. So I'm going to put start and I'm going to put Guam. So I'm going to dot this. We went there and we came back. Okay, so that's the first sentence. The trip there took 3 hours and the trip back took 4 hours. So I'm going to do this little interesting thing. I'm going to DRT, which is our distance equals rate times time, and DRT. So all I'm doing is the leg there and the leg back. All I'm doing is labeling. As my information comes to me out of the paragraph, I'm just going to fill in the blanks. Now, the cool thing about this, on each trip, there or back, if I get at least 2 items, I got the third nailed. So that's how you have to look at these. You have to keep your structure. Distance rate equals rate times time. So we have to label our distance, rate, and time. And you see I'm diagramming everything as I go along. Now, the trip there, 3, 4 back. So the trip there was 3 hours. I'll put 3 HRS. And the trip back time, that's why I have this under the T, is 4 hours. All right. So again, I read the sentence. I put it on our paper or our dry erase board. Okay, so now it's telling you it averaged 6 kilometers per hour on the return trip. So that is our rate. 6 kilometers per hour. Okay. Now, like I said, we got 2 pieces. We got our trip back nailed. Because, of course, if they give you this, they're not going to ask you what's here. They're going to ask you what's here in the unknown area. So the final question or final statement is find the average speed of the trip there. Well, we look at our return leg. We have a rate and a time. And distance equals rate times time. So the rate is 6, the time is 4. So the distance is 24 kilometers. Now, question for the room. If the trip back was 24 kilometers, what was the trip? What was the distance of the trip there? D out, D back. Okay, distance out equals distance back. That is true. So if the distance here is 24 kilometers, which was from Guam back to our original point, then our original point to Guam's got to be 24 kilometers. So 24 km, kilometers. And like I said, once we get 2 pieces of the puzzle in the distance, rate, and time formula, then we got rate. It's 24 divided by 3, which is 8 kilometers per hour. Okay. So word problems are not that hard. You just have to read the line, read each line that you see, and just diagram it. So to recap, an aircraft carrier made a trip to Guam and back. We made our start point in Guam. We also made dash arrow saying we went there and we came back. That was the first sentence. The second sentence, the trip there took 3 hours and the trip back took 4 hours. Now, new pieces of information. Boom, I will circle that. These are the new pieces of information. And what's not boxed in is what the question addressed. All right, so the trip there took 3 hours. The trip back took 4 hours. That was in the question. It averaged 6 kilometers per hour on the return trip. So that the question told us this. Again, we multiplied rate times time to get our distance, which is 24 kilometers. And then we established if the trip back was 24 kilometers, the trip there was 24 kilometers. So we put that in here, new information inside the box. And their question was, what was the average speed there? Excuse me. So we divided 24 by 3 and we got 8 kilometers per hour. And if you guys are clear in the room, please type clear. Every week, Skull Farms, every week, Friday 9 to 10. And I offer a special session for my clients, 11 to 10. But it's not like this. It is, how do I say? It is it's a video conference. And very, very beneficial. You can ask Cody. Cody's been to some of them whenever he can make it. You know, I think I'm a pretty good teacher of math and physics and all that and everything. So this is definitely a channel you want to be if you are preparing for a military aptitude test or a Federal Aviation Administration pilot exam. I've taken all of them. So it's not like, oh, he doesn't know what he's talking about. I've taken all of them and scored very well on them as well. Kind of like the thing you want to, if you're going to be a pilot, you want to be on the upper end of things. You know, I don't want to just squeak through. So that was always a thing for me, and something as when I was a full-time flight instructor, I impressed upon my students. You know, be that guy. Don't be the guy that just squeaked through. Anyways, okay, so I'm going to my email again now, and I'm looking for another question. Okay. Another problem that I see a lot of, and I just got a question on, is linear equations. And I went through that on another video, so looks like James, just go to the last video. You know, I don't like doing the same thing week after week after week, over and over again. I like to get the new information and new stuff. And if there is something you need addressed, you can go back to a previous video. And that would be the live stream last week. But here's another one. Finding the slope. Okay, how do I find the slope? Okay. So what this subscriber has sent me is, you know, how do I find a slope? Just by getting 2 points. A lot of times what a test or a teacher will, you know, kind of test you on is your ability to find the slope of a line. So M is kind of like the variable for slope. It means slope. If it's positive, the slope means rise over run. And if it's negative, it means fall over run. Now, I will get to what I'm talking about when I talk about this in a minute. So if it's positive, it's rise over run. And what I mean by that is, let's take 2 instances where we have 2 coordinate planes. we have an x value or x-axis and a y-axis. This is the x on this one, this is the y on this one. If it is a positive slope, as we look at it from left to right, it's going to go upstairs if it's a positive slope. If it is a negative slope, it's going to go downstairs. Okay, so that's what I mean by rise over run or fall over run. Now, let's talk about the formula. The formula is y2 minus y1 over x2 minus x1. What does he mean by that? I'll get to that too. So, what this means is, let's take our points. Let's input our formula. The slope equals y2 minus y1 over x2 minus x1. And this is the variable. You don't have to write this down right away. You can come back and you can go over this and go over it again. But the m is the y of the second point minus the y of the first point over the x over the second point minus x over the first point. Because what they're going to do is they're going to give you two coordinates on a coordinate plane. They're going to give you two coordinates. This one is, point 1 is 19, negative 16. We'll call that P1. And P2, the second point, is negative 7 and negative 15. All right. So just based on these 2 points, we can input that into the formula and we can find our slope. Okay. So this will be y, this will be x1, y1, this will be x2 and y2 when we're considering our formula. So now, what does that mean? y2 is negative 15. Negative 1, 5. Let's move this guy that way. And y1 is negative 16. But we got to look at the formula. y2 minus y1. So we have to put a negative sign, parentheses, because that's a negative 16. And we're going to have some distribution going on there. The x's, this is x2 minus x1. All right, because that's our formula. So negative 7 minus 19. I put that in parentheses as well. Now, let's see what we got going on here. The negative is going to have to distribute into the parentheses, and so it will be positive 16. So the upper value or in the numerator will be 1. Because positive 16 and negative 15, the result is 1. And on the bottom, the negative distributes into the 19, and then we'll have a negative 26. Now this is a pretty rise, a pretty shallow slope, which means if we looked on the coordinate plane here, all right, and we had a given point here, we would rise. No, it's negative. I'm sorry. So let's put this point higher. Sorry guys. So that would be fall over run. So we're gonna fall 1 point and run 26 points. We'll fall 1 point and run 26 points. All right. So like I said, that is a pretty shallow slope. It's not steep at all. All right. So that's what we mean by fall over run. If it was rise over run, then it would be going upstairs as we looked at it from left to right. So the major thing that people have issues with is this part. You've got to isolate your numbers because this negative has nothing to do with negative 16. This negative has nothing to do with positive 19. So what I've done is encased them in parentheses so they could be dealt with, you know, like as they should be. So our slope is negative 1 over 26. Was that clear to you guys? And if you guys would please hit the like button or dislike button. If you feel like I'm doing a terrible job, hit the dislike button. You know, YouTube, you know, they like to track our activity and all that and everything like that. So either like or dislike. Doesn't matter. I mean, I would hope it's a like, but you know, there's trolls in the area. Oh boy. I'm going to leave the trolls alone. I'm going to make a conscious decision to even just stop talking about them. But they're funny. Very funny. All right. Let's see. Next question. La, 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 la. All right. Give me a moment, guys. I was just trying to look for something different that I have not covered before. Another one. Word problems. Yeah. Okay. A lot of people have issues with these only because it doesn't mean you're slow or anything like that. It just means that you have not dealt with this type of stuff before. And so it takes a little while to learn how to organize the information. Okay, so yeah, I think I can put this one up too. Yeah. Where you at? There you go. Okay. I got it. And I'm going to post it up on the message board for you guys to see. And there we go. Okay. So you guys, everybody in the room, you can see the question. And the question is as follows. Working alone, Ryan can dig a 10 foot by 10 foot hole in 5 hours. But Castell, he can dig the same in 6. So how long would it take them if they work together? So this is a working together problem. All right, so I want to get the names right. Ryan is one person. Castell is a second person. Now, this guy can dig the hole in 5 hours. Did I get that right? Yeah. And Castell can dig it in 6. So how we set this problem up is we say x over 5, which represents Ryan, plus x over 6 is equal to 1 job. X over 5, the 5 hours, plus x over 6, the 6 hours is equal to 1 job. Okay, let's take that in. X over 5 hours plus x over 6 hours equals 1 job, excuse me. Now, here's the thing. We must find the lowest common denominator. Once we find the lowest common denominator, the LCD, we're going to multiply the lowest common denominator by each term. So x over 5 is going to be multiplied by the lowest common denominator. X over 6 is going to be multiplied by the lowest common denominator. And 1 is going to be multiplied. I might have said, but these are all multiplied by the lowest common denominator. I may have said something different for this one, but that's what I mean. And Leon, very good. The lowest common is 30. All right. And multiple, I'm looking at fractions, and that's why I said lowest common denominator, but it is the lowest common multiple. Thank you for that, Leon. So it is 30, like Leon stated. Now, the cool thing about this is you have to understand the relationship with numbers. This is basically this multiplied, 5 and 6. So this is going to become 6x plus 5x equals 30. And if anybody didn't understand what just took place, just say explain. Type explain. Because I really, really want to make sure that you guys get this. All right. But since these two, 30 is a multiple by multiplying these two, the 6 kind of attaches here, the 5 attaches there, So 6x plus 5x plus 30 is going to be multiplied by the 1, and then we get 30. Okay, looks like nobody was puzzled by what I just did, and that's awesome. So now in the next line, I love these magnets. All right, so we're going to have 11x is equal to 30 because we've combined like terms. And what we simply need to do is divide both sides by 11. So this cancels out, and then we'll have 30 divided by 11. And I will always add a decimal for just a little bit more accuracy. So 11 can't go into 3, but 11 can't go into 30 2 times only, not 3, because 11 times 3 would be 33, too big. So 22 is as close as we can get. We'll get 8, and we'll drop a 0. And the closest we can get, we'll raise our decimal, because the decimal's here. We have to raise it up there for our answer. And the closest we can get is 2.7. Now, 2.7 hours. So Ryan can dig this hole by himself in 5 hours. Castell can dig this the hole by himself, the same hole by himself, in 6 hours. But working together in 2.7 hours, slightly 42 minutes, around 42 minutes, 2 hours and 42 minutes, which is good. So, you know, hey, that's why we use teams to do things. Because we can be more efficient and we can get things done faster. Okay, very good. And then type clear. Guys, I need to see my clears. I don't want to erase it too early because somebody might have a question. So I will wait a couple minutes. And if I don't see any clears, I'm just going to erase it anyway. Brother Man. I like that tag. Brother Man. I've never seen your name, dude. I'm glad you're here, and I hope you're a subscriber. And whether you're a subscriber of mine or not, I will still do these problems if you need help with something. Leon, it's clear. Okay, so it doesn't look like anybody's having any issues with that particular question. All right. Okay, I'm going to talk about a couple aviation topics for all my aviation hopefuls. Oh, okay. What's up, Alonzo? Awesome. Now, what do I want to talk about? I want to talk about plan form, wing plan form. A wing plan form is the shape of the wing or the profile of the wing as you look at it from above, like from a bird's eye view. So the glider's wings would be kind of like this, very long and thin, like that. Your Cessna, you know, like your 4-seater aircraft would have a wingspan like this. Could be it could be regular, it could be rectangular like that, or it could have a taper to it. But basically, it's going to take on. This is one with a taper. All right. The back is tapered. It's not rectangular like that. Or you could have like your airliners that have like the swept-back wings. Guys, do not laugh at my artwork. I'm sensitive about my artwork, man. All right. That's almost perfect, I guess. So that is the plan form for your airliners or business jets. And then say something like an F-16, a supersonic aircraft, would have what we call a delta wing shape. All right, and I know that is not symmetric, but hey, I'm not an artist. But you will notice something about these plan forms. And let me just spell that out, because somebody will be talking about plane forms tomorrow. P-A-L-N-E-S. and it looks like that is not coming out very well on the camera. So let me PLANFORM. This is a wing plan form. That is how we pronounce it, plan form. Now, if you notice something about the plan form as we look at it from a bird's eye view, so we're like a little bird and we're flying over the airport and we're looking at different airplanes, and these are the wing shapes that they look like. All right, so the straight wings tend to be very, very good at slow speeds. They can get to very, very low speeds. All right. And Leon, I just saw that. Let me know how you do. I would definitely like to have a conversation with you after you take that test. And here's my email, which I think you already have it. And, just, send me a number via email. I'd definitely like to talk to you after you take that test. So our rectangular wings, they operate very, very efficiently at slow speeds, where these wings operate efficiently at high speeds. All right. So you'll never see a 747 or a fighter jet with wings like this, unless it's like a weird case, like the U-2 had really long wings like that, or whatever, the spy plane. But traditionally, this rectangular form you will not see on high-speed, high-performance jet aircraft, turbine-powered aircraft. You will see the swept-back wing or the delta wing on the high-performance aircraft, because these wings are more efficient at higher speeds. These are not. All right. And these aircraft could not even slow down like these aircraft. They couldn't get as slow as these aircraft. So these wing plan forms, they kind of operate efficiently at the lower speed regimes. Like gliders can like slow down now, and I'm just guessing pretty slow. They don't look like they're moving fast at all. And there's no engine, so yeah, it can possibly, unless it's just using gravity or whatever. But like say a rectangular or a tapered wing, like something like a Cessna 172 or a Piper or something like that, with full flaps, you could probably get that thing down to probably 40 miles an hour, I'm thinking. I'm just giving you an idea. These planes could never slow down to 40 miles an hour. So they need a lot of runway. They need lots of runway, like 2 miles of runway almost, because they're going to come in very, very fast. They cannot slow down their speeds. So a lot of the aircraft that these airports that these type of platforms will be, you will find are probably at smaller 2,500 foot runways, 3,000 foot runways. Where these two aircraft, they probably need to land somewhere with a 10,000 foot runway. Okay, so if you liked the video or this demonstration, please hit the like button. I'm leaning down a little bit because the screen, the board is what you really need to see, but I'm not hiding or anything like that. So I am here every week, normally every Friday. Now sometimes I am a little late, like if I get stuck shopping or something like that. And 9:15 is the latest I'll start a live stream normally. People that are interested in the Google Hangout that have done at least 2 hours with me this week, email me if you would like to engage in the Hangout tonight. If I don't hear anything, then I'm going to go take it down. But yeah, I'm here every Friday. Every military aptitude test prep I prepare people for. ASVAB, SIFT, AFOQT, ASTB, OAR, all of them. And every Federal Aviation Administration test that pertains to fixed wing aviation for pilots. Private pilot all the way up to airline transport pilot. All the instructor ratings, all the ground instructor ratings, I've done them. So I'm an expert. That's what they say. They say if you've done anything more than 5 years actively, you're an expert. So I'm definitely an expert. So that's really all I have for you guys, man. I'll see you guys next week at 9 p.m. Remember, get your books, take pictures, send them to my email. So I will have a wealth of questions and diverse questions to cover. So it just makes the videos more interesting. So please, again, either like or dislike the video. It don't matter what you do. Just do something, thumbs up or thumbs down. And I thank you guys for taking time out of your Friday nights to check me out. Have a great evening, and I will see you guys later. I don't have my little thing. I got to go back to my finger, but it's all right.